we're going to create our own data set. So you can get rid of everything except your kind of front matter. And now, let's say SVM support vector machine with polynomial features. We're going to build the data. I'm going to go capital X, lowercase y is equal to sk.data datasets dot make underscore moons. And that's going to be n samples is equal to 100. Let's go noise is equal to 0.15. Let's go random underscore state is equal to 2. It doesn't really matter, but that just gives us all the same answers. You don't have to do that if you don't want. Whoop. Random is equal to 2. Noise equal. There we go. And that should create data's points. Now I can go ahead and plot it. So plt.figure, plt.plot, and let's go capital X for comma 0, square brackets, for y, lowercase y, double equal sign is equal to 1. So for every y that's equal to 1, we're going to plot the x. Sorry, for every y that's equal to 0, we're going to plot the x. And we're going to do that again. But now I need for my x in my second column. Comma, we're going to make it a square. Just so we have different different shapes. I'm going to copy this line, do it again, but now it's for y equals 1, y equals 1. Now I'm going to make it a diamond, just what we've been doing. Capital X. All right, you should have a moon, some moon shapes that look a bit like that. You have moon shapes that look a bit like that. Maybe you can up the noise if you want, 2.5. I'm going to up the noise, just make it a little bit less moony. All right, I want to build a classifier. So I need to make a 2D space for the colors. So that's going to be x1 is equal to np dot linspace. We're going to go from negative 1.5 comma to 2.5 to 100. And x2 is equal to np dot linspace from negative 1 comma 1.5 comma 100. And now I need to make a grid out of that. So x1 underscore grid, x2 underscore grid equal to np dot mesh grid x1 comma x2. And now we're going to calculate the binary decision and prediction values. So that's going to be capital X2 is equal, oh, sorry, that's not a comment. So, sorry, comment, calculate binary decisions. I need values to put into my 2D color map. And I'm going to go x2 equal to np.vstack. I need to open up that parenthesis, open up a tuple inside of that. It's going to be x1 underscore grid dot ravel, open and close brackets, comma, x2 underscore grid dot ravel, open and close brackets. And then I should be able to close that tuple, close that expression. I do need to take a transpose of it. Probably a cleaner way to do that, but that'll work. Y underscore prediction is equal to SVM classifier, SVM underscore classifier dot predict. I want to predict for all of my X2, that's my unraveled grid space. But now that I've predicted it in my unraveled grid space, I need to ravel it back up into a grid space. So it's going to be dot reshape x underscore 1, wait, x1 underscore grid dot shape F5. Is not defined. Okay, so S support vector underscore CLF. Did I not build a pipeline with that? Did we totally miss that? We totally missed building our classifier, right? Whoopsie. Build the support vector machine. That's the most important part. So SVM underscore CLF equals sk dot pipeline lowercase p dot pipeline with a capital P. Open and close my brackets, open and close my list, break it down to a new line. Now I want to add a poly features to this. So before I do anything, I'm going to create an extra bit of polynomial features. And so I'm going to open up a tuple, open up a string, and call it poly underscore features, comma, sk dot pre-processing dot polynomial features, capital P, capital F, degree equal to 3, and that's going to add that to that pipeline. Close out that tuple, hit a comma, new line. Now I need to scale this because this is very poorly scaled. Scalar, comma, sk dot pre-processing dot standard scalar. Kick it down to the next line. So now I've added my features, I've scaled them. So I need to actually create my support vector machine. So in quotes, SVM underscore CLF comma sk dot SVM dot linear SVC. I'm going to make it C equals 10. Pretty tight on this one. Hit F5. All right, this polynomial features instance is not fitted yet. Oh yeah, we should probably train it. So svm underscore clf dot fit, everyone's favorite capital X comma Y. All right, it's not converging, but that's just something we can remember when we plot it, that we might not have a perfect answer. So Y prediction, back to my Y prediction. I need Y underscore decision is equal to svm underscore clf dot decision underscore function x2. Now I want to reshape that into a grid space. So reshape into x1 underscore grid shape. Has no attribute reshape. svm underscore clf dot decision x2 np.nd array object. Oh, thank you. Thank you. Okay, perfect. Okay, now we can go ahead and plot our figure. So plt.figure. And we are going to provide a solid background color for classification. That's plt.contour x1 underscore grid, comma x2 underscore grid, comma y underscore predict. I'm going to go, we're just going to try it. Woohoo! How about that? So that is our contour decision maker for our data, but we haven't actually put our data on yet. I can go ahead and copy this over. That's my prediction. I can also do my decision. Right, and that'll give me some nice kind of confidence interval lines. However, the confidence interval lines are a ways out, right? So they're not super useful there. So let's go ahead and define some confidence interval lines. Call it con underscore lines is equal to maybe negative 10 comma negative 5 comma negative 2 comma 0 comma 2 comma 5 comma 10. Not a ton of confidence lines, but we can give it a shot. And that'll come down here after confidence line, after your data, and you should be able to get, okay, there's kind of some cool confidence lines. You know what I kind of want is a negative 1 comma 1 comma. I want some confidence lines that get a bit closer. There we go. Right? And so you can see that stuff out here you're really confident in, and as you get closer and closer, you're less and less confident, which makes sense. All right, I think it's time to throw our data on top of this. And that is a support vector machine nonlinear classifier for our moon data. Everybody likes moons. Right, and I guess we probably should add some labels to this. It's not a huge thing, but plt.x label. It's going to be x underscore 1. And plt.y label is going to be x underscore 2. Maybe you want to put those in math mode. And there you go. There's a nice nonlinear line. If you want to change it from contour lines to field, you can do contour F. Although I think the colors are pretty ugly. It's not so bad. It's just kind of a little hard to see. So maybe we could do like alpha equals to 0.1. That'll just wash it out a lot. Maybe we set this alpha lower. And this alpha. We'll just try them both low. Oh, there you go. That works pretty well. Maybe that one's like a bit darker. Yeah, that's ugly. It's not bad. And then you can see your nonlinear classifier solved using quadratic programming in a linear plane. But the data is warped back onto itself. And that's what we were looking at when we looked at this picture, right?